Hey everybody. Today we're going to talk about linear interpolation, which I think is pretty cool. Um, the basic idea behind linear interpolation is the principle that what is a good approximation of a missing data point. Um, if we have no knowledge about the circumstances. Okay, so for instance, let's say you know how tall you were at age 10, and you know how tall you were at age 12. Okay, so here we are at 10, here's what your height was at age 12. Now the question is, how tall were you at age 11? I shouldn't put a question mark here. What I should do is I should put my question mark up here. What is your height at age 11? Now, the thing is, around that age, you're growing at variable rates. So, the answer could be you grew really, really fast and then leveled off, or maybe you were kind of in a slow growth spot and then you increased quickly. But if we don't really know how we were growing at that point, maybe the best way to get a guess is to say, I'm going to guess that we're growing linearly from age 10 to age 12. And in that case, to figure out what the value is of your height at age 11, you'd take the average of the height at age 10 and age 12. So this idea of an interpolation is finding a best guess for what missing data points are that are in between known data points, and that's to be in contrast to trying to figure out what your height is at age 18. That would be more of an extrapolation. Okay, so um, what we're saying is we're trying to find a data point in a range, and if you have 2 points, you can use 2 points to figure out what the value is anywhere in between those 2 points. All right, so let's talk about the uh, math behind that. So what we're saying is, let's do a parametrization of this curve where let's want to parametrize this curve. Now it's a line, but we'll call it still a curve. Parametrize this curve, and we'll say let the curve from point A to point B. All right, and we're going to let t be equal to 0 at point A and t be equal to 1 at point B. Then what we're doing is we're taking, so we've got our point A and we have our point B, and we're thinking of these as vectors. And so what we want to do is we want to take a linear combination of these two vectors so that we stay in the line between them. And so the way we can do that is we can say, okay, at time 0, we're here at point A. And along the way, we're going to add a multiple of B. So what we're going to do is we're going to take the vector from A, we're going to multiply by 1 minus t, and the vector from B and multiply by t. So when t is equal to 0, we get 1 minus t times a. So 1 minus 0 times a plus 0 times b. And so from that you get 1a plus 0, so that's just a. And then at time 1, where are we? We're at 1 minus 1 times a plus 1 times b. So that's 0 a's and 1 b. So we are at b. And you can see that as t changes, then we move slowly from a to b. And in fact, we can use this no matter what the dimension of the points is, and we can even extend this backwards, and we can say, well, what happens if we have we add negative copies of b to this vector? So what this is saying is that the line that goes between the lines, maybe not between, that goes through the points A and B can be parameterized by the function 1 minus t times A plus t times B. All right, and we'll go over to Mathematica in a second and see that. But parameterization, linear parameterization linear interpolation, excuse me, can be also used to create some surfaces. So let's say we have one curve, C1, and we have another curve, C2. All right, and then, right, so a curve has maybe some endpoints, and I guess we'll let u be equal to 0 here, and u be equal to 1 here, and the same thing with C2. We'll let u be equal to 0 here, and u be equal to 1 here. Well, what we can do is you can take these curves and you can, at every point t, you can connect, every point u, you connect the point on C1 with the point on C2. Right? And so the curve, by introducing a second parameter, we can create a surface that interpolates between two curves. And so, for example, if C1 is equal to R of u, where u is between two endpoints, which are the same for the second curve, maybe that's R S of u for u between 0 and 1. Oops, I shouldn't put u is just a parameter. U is just a one-dimensional parameter. Then the surface is defined as S of ut, or no, I guess this was my capital S, not to be confused. So let me not change it to be S. Surface Q, because I need a letter, see, Q u of ut is, well, the same thing that we did before, which is we do 1 minus t times r of u plus t times s of u. And so u goes between 0 and 1, and t goes between 0 and 1. And then this linear interpolation is a surface that goes between those two curves. All right, let's head over to Mathematica and see this in action. All right, so what do we have here? Let me make this a bit bigger. So we're choosing 2 points. A, that's this point here, 1, 2. And B, here is -1, -3. And we're displaying them on a graph. Now what we're going to do is we're going to interpolate between those, and that's going to create the line between these 2 points. So the line between these 2 points is going to have, it's going to start here at t equal at lambda. I guess I'm using lambda here as the parameter instead of t. But as this t starts off at 0 and goes up to 1, this lambda goes from 0 to 1, we start here at our first point, and we end up at the terminal point. And so what we have here is now a line that goes between those 2 points, and if we extend lambda to be negative, then we go, we're on this side of this point, and if we let lambda get positive, then we end up on the far side of this point. But everything between 0 and 1 stays between our 2 points, 1, 2, and -1, 3. And if we were to change these points, maybe we make this -1, and we'll call this 2, 3. So here's some new points. We could run this again with these new points, and the same thing would happen. You've got a line that goes between those 2 points, and here is the interpolation, and our parameter parameterizes the line between them. All right, let's talk about these surfaces. So let's say we had 2 surfaces, 2 curves. So here's f of t, and here's g of t. And let's say we want to make a surface that interpolates between them. Well, we have here we have our 2 curves, and if we do an interpolation between them, then we get a surface that basically at any value along the way, it creates a line between them, but when you put it all together, it makes a really snazzy surface. We can do this for a helix and its partner, so this is a double helix. And then if we make the linear interpolation on that surface, then we get this really cool spiral surface. All right, so I'm going to share these with you, play around with them, and show us what you can make. All right, see you later. Bye.